Hello and welcome to the section of the Matlab tutor. Here we're going to continue learning how to plot graphs in Matlab, and in this section we're going to learn how to plot functions. Importing raw data is one thing, and typing it in and doing an XY scatter plot is great, it's useful. But a lot of times in pure math and engineering you want to plot a function. You'd like to plot, cosine x, or you'd like to plot sine x or something like this. So the easiest way to do that is to generate a listing of xy points from the function that you want to plot, and then just plot it like we did before. So for instance, if we're going to generate the x values, we can just type them in, but we've learned before that we can generate a list of x values pretty easily. Let's say x is going to go from 0 in increments of 1, okay, to 10. Or let's say, let's do 10. Like this. So what this means is I'm creating a little single row vector from 0 in increments of 1 up to 10. So instead of typing it out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm going to do that, and I'm going to generate this row vector automatically. And then I'm going to define another variable y. And I'd like to, have a function. Let's say I'm going to plot y is equal to x squared. So what you would think is you would do x squared like this, because that would take the values of x and it would square them. But if you remember back to when we talked about working with vectors and doing the computations with vectors, if you want to do an element by element calculation like that, you need to put a period right in front of the operator. So what you need to do is period and then the exponential right here, the exponent here. And what that tells Matlab is we're operating on each value of x separately, and we're raising each value to the power of 2. And I'm assigning the resulting values in terms of y. So here is really, I'm just defining my function in terms of the x data I've already put on the screen. And when I hit enter, now you can see I have the raw data. So you see you can do this for any function you can imagine. You generate some x data, and then you generate some y data, and then you can simply use the plot command x comma y to view the data. And this is roughly what it looks like. All right, so you can see it goes just like a parabola like this. Now if you decide you want to change it a little bit, then all you'd have to do is, let's say you wanted to go and look at some negative values. So go up, up arrow, and up arrow, and up arrow where I've defined my x data. And I can say, okay, maybe I want to go from negative 10 to positive 10 in increments of 1. So I can hit enter, that redefines my x data, and then I could go up arrow, recalculate my y data using exactly the same calculation as before, and then up arrow, and plot the resulting data that I have. Go back to my graph window, and you can see now the axes have all changed, because now I have the x data going from negative 10 to positive 10, and I have the corresponding y data there as well. All right, so that's super important, and like I said, you can do that for any function, and we can go and insert x axes and y axes and titles and things like this. But what I'd like to do now is switch gears to show you how to plot multiple plots in the same graph, because a lot of times you'll be needing to do that. So let's go and clear the screen, and let's define our x data just much as we've done before. Let's go from 0 in increments of 1 to 10. So we're redefining it from 0 to 10, looking at positive values. Those are our x values. And for our y value, let's pick something a little more familiar. Let's say y is equal to the sine of x, right? The good old sine function. We all know what that looks like. And the sine function is going to operate element by element, and so we're going to get a listing of numbers back, that many elements long, and it's going to be the sine of each of these discrete values that we've calculated. So we can plot this, x comma y, and take a look at it, pull up our graph window, and notice we have a pretty ugly looking sine wave, right? It's clearly not right because, it's got a lot of curves, it's got a lot of changes, and so since we chose our x data to be kind of coarse like this, the graph is going to look kind of ugly. So if that happens to you, and I did this on purpose to show you, just go back and redefine your x data. See, what I've done is I'm going from 0 to 10 in increments of 1. Well, just change that. Go increments of, let's do 0.1. So this is going to generate a whole lot more x data because every point is spaced apart by 0.1 along the x-axis. So when I hit enter here, actually I've already overwritten what I was trying to do. When I hit what I'm trying to do here, let me go ahead and do it again. X is equal to 0 colon 0.1 colon 10. That's what I'm trying to do. And I'm going to hit enter. Okay, I've got that data. And you can see lots and lots of points now. Everything's spaced apart nicely. And then I can define y is equal to the sine of x, like this. And it's going to generate a calculation for the sine of x for every point that I have here. And if I hit enter now, it's going to flood the screen again. So I can just put a semicolon there that does the calculation, but it suppresses the output. So let me clear the screen like this. And now we have x data and we have y data. And if you look over here in the workspace, you can see the x data is 101 elements long, and the y data is also 101 elements long because we calculated y is equal to sine of x. So now we plot x comma y and bring up our plot window that we have here, and we notice our sine wave looks much, much more reasonable. It's still a little bit coarse and bumpy in some areas, but it's pretty darn good. So if you're plotting a function, it's worth your while to go ahead and pick, it's a computer, it can handle the calculation. So just pick some points that are closely spaced together if you have a function that's changing a lot, right? And you can go in here and hit the trace button and drag, hit the arrow keys, and you can look at all the points that you've plotted here. So that's the basic idea of plotting in Matlab. The most essential fundamental way that the program is designed to handle plotting is basically to calculate the raw numbers and to do it. And this is a very manual process. You define x, you define y in terms of a function of x, and then you plot the xy points. So here we have x data, which is a lot of stuff. Here we have the y data, which is a lot of points because that's in terms of it. Let's go ahead and calculate another function. We'll call it g, and we'll call it cosine of x. So we already have the sine of x defined. Let's go ahead and put the cosine of x there. And again, in order to avoid the screen getting flooded, I'm going to put a semicolon at the end. The calculation is done, but it doesn't put it on the screen. Notice that g over here is also 101 elements long because I'm operating on all of that x data that I have. All right, so if I'd like to plot the cosine, it works the same way. X comma g. So I'm plotting xy data, x data on the same axis, or x comma g data because it's defined in terms of an xy pair. Hit enter, and now I should see a cosine starting at the top and coming down like a typical cosine. So the question is, how do we display both of these graphs at the same time? We have the cosine data, we have the sine data. How do we get them both to coexist on the same graph? Well, we still use the plot command. Here's how you do it. X comma y, that's the sine data. And then you have to put another comma and do x comma g. Matlab knows when it gets multiple arguments inside this plot command that the first two are going to go for the first graph and the second two are going to go for the second graph. So you have to have x and then your first function, x and then your second function. And then when you do that and take a look at what you have, you're going to get two nice looking plots on the screen, right? One of them is blue like this, and one of them is green. And so basically what you're doing is you're calculating, you're defining the x values, right, that you're going to plot over using the matrix methods and the vector methods we talked about, and then you're defining the functions. In this case it's y and g. You're defining them in terms of the x data that you have. You're calculating them, and then you're basically plotting them. So it's a little different than a graphing calculator where you just type a function in and it does it all. Matlab, the built-in default way to plot data is to basically calculate the data. But once you get the hang of it, it's very, very efficient and very quick. And I think they do it this way because you're using Matlab so much for experimental data where you're pulling in functions and you're pulling in data from a file or something, of some data that you've collected, and you're plotting those points relative to XY scatter plots. And so the easiest way to plot functions is basically to do the same thing. You generate your own data and you plot it. So that's how to plot a function in MATLAB. That's how to plot a pair of functions in MATLAB. Follow me on to the next section where I'll show you how to tweak this graph a little bit, make it a little bit more presentable so that you can kind of distinguish what you're looking at.